Okay, question 9 is going to be about energy transfers. So figure 23 shows a drone. The drone has 4 spinning blades. So already I can see we've got kinetic energy. The upward force enables the drone to rise into the air. The speed is measured in turns per minute, and I can see that down here. The graph below shows the upward force. Given that speed, describe the relationship. So we can see as this increases, and we're just going to use the exact same words on there. And the next part is we then discuss, is it a straight line, in which case that would be directly proportional, a linear relationship, or in this case here, it is a curve, it's non-proportional. So model answer for that, as speed in turns increases, so we're just using this, state the x-axis first, the upward force in newtons increases, so then state the relationship in y, and it is a non-linear relationship. Okay, so the next part, a different drone's got a mass of 4.5 kilograms. It rises 20 meters. Calculate the gravitational potential energy given that G. So we know GPE equals mgh, and we can see there's m, there's g, there's h, and we just got to multiply it all together. And again, that will be in your equation booklet at the back. So GP equals mgh, 4.5 times 20 times 10. Gives us that energy there. Next one, state the useful amount of work done. So we need to know that, well, energy is equivalent to work. So we transfer energy to do work, and fat wobbly dinosaurs. So that energy here, the work, has been used to raise the drone with a force a given distance. And then that's given it GP at the top. So what do we know? Well, the work and the energy we gave it are the same thing. So 900 joules. And a nice little tip is you can see that's a 1 marker. So you do not need to do any calculations. Some students will get their fat wobbly dinosaurs equation ready and go through, and it's 1 mark. So we can just see we're bringing that down. Next part, it takes 4 seconds. So we've got a time for the drone to rise through 20 meters. Calculate the useful power. So time and power developed by the blades. So we can see for power, well, we need our PET formula, P equals E over T, and the energy is up here or there. So we've got to pull this down again. We see on higher tier questions, we're working something out to then use it lower down. So P equals E over T, and then we can just use those values. So P equals E over T, 900 over 4 equals 225 watts, or 225 joules per second, or I could write that as joules second to the minus 1. Okay, on to the next question. Next one. The blades on the drones are turned on by motors, so I'm going to have to talk about those. The motors are powered by a battery. I'm going to have to talk about that. The Sankey diagram below shows the energy transfers involved, and we can just see, okay, we've got battery, chemical energy store. It's going to go to the motors. They're going to need electrical energy. That's going to go to the blades, kinetic energy. After that. And then that kinetic energy is going to be used to give the drone GPE. And the crucial bit that we're looking at is on each of these steps, there's a small amount of waste energy, and that must be the thermal energy that's wasted and then dissipated into the air. And we can see that we do not get as much GPE out as our useful output energy compared to the total chemical energy in the battery, because at each stage there's energy being transferred to thermal energy. So now we've just got to put all of that together, and with those 4 energy transfers and the idea of thermal energy being dissipated, that's our 6 marks. So the battery has a chemical energy store, mark. This will transfer to electrical energy in the motors, mark. This will transfer to kinetic energy in the blades, mark. Kinetic energy will transfer to GPE as the drone rises. And then we go on to the last part. Each of the downwards arrows show a small amount of thermal energy is wasted at each stage. I've got the thermal energy in there, and that will be dissipated into the air. Okay, so we get less useful output energy than the chemical energy that we put in. And you'll notice I've used that for my shorthand, but I've used the full words. Now, GPE, we can leave GPE and EPE. They're absolutely fine in terms of the shortened versions. So that's that question done. I think that's quite a nice 6 marker. Please remember, try to use that help to suck. Magnets, in terms of all of our energy trait changes, so we've got heat, electrical, light. Then the P2, there are two with P in the middle, GPE, EP, gravitational and elastic, sound, nuclear, chemical, kinetic. Now, the reality is these do not come up very much because, as I've said to you, physicists will try to distill all of these down into simpler forms. We could argue that these are other types of energy. There we go.